Hey everybody, welcome back. Thank you for everybody who's returning to my channel. If you're just finding it for the first time, my channel is, wow, just about 2 months old now, either like today or in the next couple of days or something like that. And thank you everybody who's liked my videos, subscribed to the channel and all of that. It's been really fun starting this YouTube thing out as a hobby. Now what I've got for you guys today is some hardware news for PC hardware stuff. We got some info about the 6900XT performance leaked in Geekbench. We've got some leaked Geekbench results for the Intel Rocket Lake S 8-core 16-thread CPU. We have some information about possible like AMD versus Intel Marketshare results. That's a little bit interesting to take a look at. Some information about what we might be seeing from Lisa Su at CES. And I really found this interesting myself because I've been really looking carefully at this Apple M1 chip, their Apple Silicon ARM-based stuff that they're doing, and it's looked really impressive, almost too impressive in some of the benchmarks. And so this WCCF Tech article has some very interesting information that I think you guys might be interested in as well, due to not really Apple like lying about anything, but just the way certain benchmarks work for single-threaded performance, possibly making it look better by comparison than it really should. We'll dive into that one at the end today. All right, let's get started right here. And remember, as everybody who has subscribed to my channel is used to, links to everything down in the description today. All right, so the AMD RX 6900 XT has been spotted on Geekbench. This is Geekbench, right? Yeah, it's Geekbench. Okay, Geekbench is where we see, and no, to be clear here, this is OpenCL scores, so this is compute stuff. And I'm gonna say that none of this is too mind-blowing. Basically, it does better than a 6800 XT, right? By about 12%. And about 35% faster than the 6800 non-XT, and that would make sense because that's about how many more stream processors it has than both of those. So that would make sense. Now again, it's losing to a 3080 and 3090, but this is a compute, this is OpenCL, this is not a gaming benchmark. So if you do see this reported in other places, just keep in mind whether or not this is a gaming benchmark. So if you're interested in gaming, not compute scores, don't read too much into this. Remember that card's coming out on December 8th, and given the way prices are right now, if you gotta buy something right now, $1,000 is unfortunately about what a lot of other cards are costing. So I definitely recommend wait a few months for supplies to settle down. But you know, if you need to buy something right now, I don't know, man. Grab one of those at launch at MSRP, and at least for the next couple of months, that might not be a ridiculous price. All right, let's jump over to some more Geekbench leaks, which is an Intel 8-core 16-thread Rocket Lake S CPU being leaked here. Now, we don't know the exact model. We don't know if this is the highest end version of the Rocket Lake S, so keep that in mind. It's not, but basically, if you grab the scores and you compare them to some other processors, let's see what we get. And thank you, videocards.com, for making this handy dandy chart for me, so I don't have to bust out my calculator and do the percentages myself. So we've got the Intel Core i7, you know, something or other here. Set to a 100% score. Now we've got our single core scores and our multi-core scores. And if we compare these things, notice that it is doing better by, you know, it's got that 14% jump here compared to the 10900K, and compared to the 10700K, doing even better. Now, in terms of single core compared to the Ryzen 9 5900X, it's basically tied. And compared to the 5800X, it's once again basically tied, right? That little 1% gain isn't something you would really notice. Now, I feel like this is a really big deal because it's this latest Zen 3 CPUs from AMD have finally given them that single core performance lead, and that affects gaming a lot, right? So that's where they started claiming that they'd taken over the gaming crown from Intel. Well, it does, at least based on this, look like Intel will be firing back to at least catch up in terms of single thread performance. But again, we don't know exactly which model this is. Could it be a higher, could there be higher models out there? This could just also be like an early engineering sample. You know what I mean? So we don't know what the final performance is going to look like, but it looks like there's good evidence here that they'll at least be catching back up in single thread performance. Now, multi-core scores, it looks like this particular chip is not going to be dominating your 5900X or something like that. But again, we don't know if this is their top end chip or anything like that. So we don't want to read way too much into this than we should, but it is cool to see that big performance jump in the single threads for Intel, because I know some people are like, AMD fan, you want them to just kick Intel in the teeth and just keep them down. Well, personally for me, and I think most PC hardware consumers, what you're thinking is, what we want is competition. We want these companies pushing each other to do the best they possibly can, and hopefully we'll see Intel waking up and competing here a little bit better. So that's what I'm hoping to see out of this. Now, jumping over to this chart, this is a Reddit post I took a look at, and if you zoom in a little bit more on here, what is this? So speaking of the Intel versus AMD situation, well, this is a market share thing. Now, this isn't market share of everything. Apparently, this is specifically for mindfactory.de, so I'm pretty sure this is a major, I think the biggest German seller of PC components, but I'm not German, so I could be wrong about that. But if we look at the market share over time here, and I realize that I'm kind of in the way. Where's my disappear button? Come on, where's my disappear button? Here, I disappeared. I'm out of your way now. So if we look at the price trend over time, we see the Intel prices going up. I think they were having supply issues on their node or something like that, which caused their prices to increase dramatically. And then we can see that the market share has a direct relationship to price. So as the Intel went up, the AMD sales got better. So anyway, just found that to be some interesting information. Again, if you're thinking about this competition stuff, I am back. All right. Now, again, speaking of AMD, we do have some information about the CEO of AMD, Lisa Su. We'll be talking at CES 2021 on January 12th. It's right there, and I can't even say it. January 12th. Now, what will the presentation be about? What would we expect to see? We'd expect to see their 5000 series mobile processors launched, because at last year's 2020, well, I guess that's technically this year, but by the time we get to January, it'll be the previous years, right? You see what I'm saying? Is when they announced the 4000 series mobile processors. We would also be expecting that to be a convenient time for them to announce officially their 6700 series, which we all know is coming and have already seen a lot of leaks about, and I've reported on some of them on this channel. But again, that would be a convenient time for them to report on that, because we have seen the, what should I put it? The release date of these is expected to be in January. So it would make sense to have that be a big press event happening right there. And again, we could see some talking about the Threadripper 5000 series, and we could be seeing their socket transition discussed as well to AM5, because again, we are expecting Intel and AMD to be moving to new platforms that will take advantage of technologies like DDR5 system memory, which is pretty cool. So, personally, I've been thinking about building a new computer, but I'm kind of waiting maybe for this new transition to where we'll be switching over to DDR5 memory and more of the PCIe Gen 4 supported a little bit more widely, things like that. So I'm kind of thinking about waiting until then for a full rebuild. All right, last thing I wanted to talk about today was this Apple M1 chip performance. Now, I found this fascinating, because ever since I started seeing and reporting on the leaks of the Apple M1 chips, like beating pretty good x86 Intel and AMD processors in single thread performance, I was like, I just feel like somehow there's a flaw with this, right? It just seems like because you're comparing ARM to x86, that this just doesn't seem right. There must be some kind of a flaw here. And it looks like there sort of is in benchmark, in the way benchmarks test single thread performance. So like I said, this article is here at WCCF Tech. They're going to go into way more detail with this than I will. So you can click on this article in my description if you want more info. So here's how I understand their explanation of what's going on. Basically, in an x86 chip, when you're doing a single thread performance test, it's feeding it a single thread. And so then the processor is just processing off that single thread. But that is not utilizing the entire x86 single core. So usually when you're actually doing real-world tasks, there will be two logical threads fed into your x86 single core. And that single core will actually operate off of both of those logical threads. Now, that will not double your performance. I believe in this article, they're saying it gets you somewhere like 20 to 30% more performance out of that. So basically, if you just feed it a single thread, it's not fully utilizing your single core. You need to feed it 2 threads per core to fully utilize and saturate that core. Whereas apparently the Apple M1 chip on their ARM architecture is fully utilized by one single thread being sent to a single core. So that can result, when you're just doing these synthetic benchmarks where you're comparing single thread performance, that can result in the M1 chip seeming to have better performance versus the x86 chip than it actually would in a real world situation where the x86 core, single core, would be getting sent to threads. Okay, now, by reading this, I wasn't sure if that applied to chips that don't have hyperthreading, or the AMD version of that, whatever that's called. So I think this might only actually apply to things with hyperthreading, but maybe I'm wrong on that. Again, you could read this article. I couldn't get that distinction out of it myself 100%. So that's still a question mark for me. Maybe you have more info in the comments. Now, if we look at how that actually happens, like what happens. So to prove this concept, they took Cinebench and did a really interesting thing. So they set the core affinity to 1 core, so that's only going to be running on 1 core. But they allowed it to send 2 threads to that 1 core, and then compared the results on the same chips to running 1 thread to 1 core. And they did see this performance boost that they were expecting. For example, here your AMD Ryzen 4800U, when it's given 1 thread for the 1 core, they get the score of 1230. And then when you give 2 threads to that same 1 core in that same chip, they get 1552. Right? So you do see a performance gain as expected. Again, comparing the same chips with each other, the 1020 goes up to 1388, your 1181 is jumping up to, 1519, and then look at that Apple M1 chip. So the Apple M1 chip, which had been beating all 3 of these when they were limited to a single thread for their 1 core, is now behind these 2 when they're allowed to feed 2 threads to the single core. So again, still just using 1 core. So this is a single core workload. It's just being fed 2 threads. Interesting, right? So they are seeing between a 20 to 30% increase there, like they said. And so their suggestion here is that we would need that benchmarker, right? These benchmark tools, the synthetic benchmarks, should take this into account and at least offer a setting where the single thread performance can still be fed more than 1 thread to fully utilize it. This wasn't an issue when we were comparing x86 versus x86 because both of them were limited in the same manner when you're comparing 2 x86 GPUs. But if we're going to now start comparing these tests with other architectures like this Apple chip, it's maybe not giving you an apples to apples comparison. And I stole that joke from WCCF Tech here. Sorry, the apples to apples pun there. Sorry. Anyway, I liked it though. All right, I'm a big fan of bad puns. Okay, anyway, I found that fascinating personally. I'm so interested in what's going on with the switch to ARM here. I'm very, very curious to see how Windows is going to respond to this. Because those Apple M1 Macs, despite this thing that I'm saying here, if you actually look at how snappy those M1 MacBook Airs are and things like that, it is very impressive. And I really hope that we can start seeing some strong responses to this. Again, I'm a fan of competition and innovation in the market, and I think we're seeing that here. All right, guys, I don't want to keep droning on. If you made it to the end of the video and you haven't yet, you could think about subscribing to the channel if you're interested in PCs, technology, gaming, that kind of stuff. And I hope you guys have an excellent day.